All right, let's go. I'm Peter. I work for Second Quadrant. We were mentioned in the keynotes earlier today. And I want to talk about what I think is one of the sort of hidden gems or unsung heroes of the Postgres ecosystem, which is pgbouncer. So this is going to be very general, so what you can do with pgbouncer and what it is useful for. So this is very basic. What does pgbouncer do? If you just look it up on GitHub or the internet, it calls itself a connection pooler. And so this is what you do with it. You have a database client that you want to have connect to the database. And the role of pgbouncer is to sit in the middle and route connections through, and then do interesting things in the middle. And this is what the talk is going to be about. Right. Also, a quick introduction of how pgbouncer is configured. There's a configuration file that you have to set up yourself, which is in this .ini format. And if you pass the configuration file on the command line to pgbouncer, and if you use a packaged installation like RPM or Debian package perhaps, then it's usually at this standard location, but you can put it anywhere you want. And we'll go more into what this actually means, but there's two sections in this configuration file. One is it tells you how you want to route your connections, and so if I'll go into the more details of this. But basically, it's if you connect to pgbouncer and you use this database name, it will actually connect to what is over there. And then there's a sort of a general configuration settings, which can be quite long. You set up sort of some general settings, like what is the port number, and various timeout settings, and size settings, and things like that. I guess sort of the minimal set you have to set is what port you want to listen on, and the Postgres default port is 5432, and the pgbouncer are sort of not necessarily a default, but sort of the recommended or customary port is 6432. In very old versions, you might also see port 6000 used. So connection pooling, that's sort of the main, also primary use case that people think when they hear about pgbouncer and similar things. So you have a client with an application connects to the database, right? So that's your standard setup. If you have this, you need to take care of a bunch of things in your application code. So you open database connection. What happens if the database connection dies? Depending on how your application is structured, you have to maintain a bunch of different connections. If you have sort of this was sort of the problem when you had very simplistic PHP applications, they would open a database connection for every page call, right? So this can be very problematic. And there's more sophisticated solutions available for this now, but maybe you don't actually need to go there because you can just do this. You have you install a pgbouncer instance, you can run it on the same machine as your client, for example, and then you just have the application connect to pgbouncer, which is very quick, so you can kind of do it a lot more often, and you don't have to worry about it so much, but maintaining your connections, and if the connection dies, you can just make another one. It's very quick and simple. And then pgbouncer does all the hard work of actually maintaining the connections to the backend. So the first thing that then people ask is like, well, if I do this, how does that affect performance? Because you have another thing in the middle, right? So I did some tests, and maybe you can't see the numbers all the way in the back, but I'll go through this. So this is first test. I wrote a very simple libpq C program that opens the connection, does some basic error checking that the connection was actually established, which was actually my first mistake because I wrote this program without error checking. It was really fast. It turned out it didn't actually connect. It just sort of blasted through, right? So that was a problem. Do some error checking. So connect, do some basic error checking and disconnect, running no queries or nothing, 10,000 times. So then you run this, you do a direct connection to Postgres. In this case, it took 24 seconds. You run it through pgbouncer. So what you're actually doing is you're actually connecting 10,000 times to pgbouncer, but pgbouncer maintains the connection in the back. Only takes 4 seconds for that point something. So that's kind of where the main performance gain comes in this case. And then I wrote threw another thing in here, which is I once wrote my own Postgres connection proxy in Python just as a sort of an experiment for unrelated reasons. So I kind of threw that at this benchmark, and the first result was, well, it didn't crash, that was good. And then it took 10 seconds. So it's still, obviously pgbouncer is written in C, a lot of optimizations have been done to it, so it's still faster. But this kind of proves the point that connecting to Postgres over and over is very slow, because it has to set up a whole bunch of database state and then all these things, has to launch processes and all these things. So this is how you save a lot of connection overhead. Second test is the same one, but instead of just opening and closing the connection, we run a small query in the middle. So direct to Postgres is, you have a little bit of an overhead here. But 27 seconds, 6 seconds. This is faster than the previous slide, so obviously there's some variations in here, and then here 12 seconds. So you can see that the overhead of opening the connection and shutting down the connection too is actually much higher than just running a query. So there is a point to this that you want to save on the time that you use to open and close connections. And this is another test. So you open a connection and then you run 100,000 select queries and then disconnect. So this eliminates the connection overhead, but now you see what the overhead of passing the data through pgbouncer is. So here pgbouncer is going to be slower because there's an extra hop in the middle. So it's 6.8 seconds, 11 seconds. My proxy was a bit slower here, 20 seconds. And then I threw pgpool in here, which is 12 seconds. So the reason I didn't have pgpool in the early ones, I actually had issues with getting pgpool not to crash there. So you see there is an overhead of routing the data through pgbouncer if what you're doing is this case, that you only connect once and then do a bunch of things, then pgbouncer is not going to buy you anything. But if you're more like the other cases where you open, close connections sort of randomly, and you want to have the flexibility of connecting quickly and doing things and then shutting it down, then a connection proxy can help you. So this is why connection proxies for Postgres were invented, and this is why products like pgbouncer and pgpool exist, but they can do more. Which is what some people also call this connection pooling. I kind of call it queuing because it's the term I made up to differentiate this from the previous use case. So this would be your setup now, right? Now, if your database client is just one client that's sitting there and you know exactly what's going on, then this is not a problem. But nowadays we have database clients that are facing the web, and there could be a large number of them, and oftentimes they're set to sort of auto scale or things like that. So when the load rises, you spin up more instances, and then all of a sudden you have hundreds and hundreds of web servers or application servers connecting, and then in a naive setup, they all connect directly to the database, and that is not going to end well, right? So you don't want to have the database, the Postgres instance, to be your first line of defense for overload. So that's why having something in the middle that protects the database is a good idea. So you want to, pgbouncer is very quick. So bombarding pgbouncer with many connections, perhaps not infinite, but many connections, will work quite well. But bombarding a Postgres database with a large number of connections is not going to work well, right? So pgbouncer can help, and the way it works is you set what's called a pool size, and then you say, well, maybe I'm only going to allow 20 connections to go to the database. And you have to pick this sort of depending on how large your database instance is. And if up to 20 connections go to PG Bouncer, it just routes them through, and database client is not going to know the difference. Everyone's happy. If more connections come, PG Bouncer makes the connections wait. And the database client is not really going to, it's not getting an error or anything. It just notices things are taking a while. So this all happens sort of on the low protocol level. So there's no, for the database client program, they don't know the difference. So hopefully a database, because it's not overloaded, it's going to be quite fast. It responds to all these 20 inquiries really quickly. And then those connection slots are freed and the next one come in. So what happens here then if you're overloaded? If you're not overloaded, everything's happening as before. If you're overloaded, whoever comes in when all the connection slots are used has to wait, but hopefully not too long because you're still churning quite quickly. But if too many are waiting, well, they're going to wait for a long time, and then you're going to have to decide somehow how you want to handle this with the monitoring system or your deployment system. You could spin up replicas, for example. So at this point, you have to kind of make a decision how you want your architecture to handle that. So there's some ways to set this up. So the configuration for this would look like this, and there's some additional settings on how to fine-tune this. So you set a pool size. Again, the 20 is maybe actually quite a low number depending on how big your database server is. But the nice thing is you can kind of tune and tweak that at runtime and see how it goes. And then you can sort of set a sort of an overflow setting, a reserve size. So 20 would be the number of connections it establishes right at the beginning. And then if you have peak, it would do up to 5 more. And then there's some timeouts to shut them down when your peak is over. And there's also a way to set a timeout. So if the client is trying to connect through PG Bouncer and is waiting too long, then it just gets killed. And then your application code will receive an error that the connection just died. And you'll have to somehow make a decision in your architecture of how you want to handle that. So the idea here is that it is better to serve some requests properly and have the other ones wait or die instead of overwhelming the database server, and the end result of that would be that probably nothing is happening, which is worse, right? So there's some ways to inspect what PG Bouncer is doing. So this is a bit, if you haven't used PG Bouncer before, this is a bit tricky to grasp. Normally, if you connect to PG Bouncer, it just routes your connection through to the Postgres database, and you don't actually really notice that there's some kind of proxy hop in between. But if you connect to this special database name called PG Bouncer, then you actually connect into the PG Bouncer instance, and then you can do some admin tasks. And it has a special sort of mini, not quite SQL set of commands. For example, that one, if you just type in show pools, it shows you sort of a list of what's currently going on. And then you can see, what database you're looking at here, and then how many clients are currently connected. So the clients are the one that connect into PG Bouncer, and then the servers connect out of PG Bouncer to the actual server. So that's the terminology of PG Bouncer that is kind of, because the server is actually the client of that guy, right? So you have to kind of know the terminology. So there's 200 clients currently active. So there's 200 clients, but there's actually only a few servers being used. So it actually sort of funnels down the number of clients to just a very small number connected to the database server. So in this, you would kind of throw your monitoring system on that to see when clients are waiting. And this sometimes happens. So I've built sort of naive monitoring systems when I was just starting out with this, and they would always alert when there's like one client waiting. And that went off all the time, so you don't want that. That can just happen very briefly, because that's what you want. You want to make sure you have your pool size, and if it goes over that, it's going to wait, but maybe only very briefly. So what you really want to monitor perhaps is this one here, which shows the number of seconds that the longest client is waiting. So, and once that goes past, you have to, again, decide that for your own requirements. Once that goes past a couple of seconds, that means your latency experience on the user side is going to be really bad. So at that point, you want to get some, events logged, or you want to get alerted or have some kind of record of that, and then you have to, decide how you want to scale out of that. So that's so we had pooling, queuing. The reason I call it queuing is because the connections then queue up, right? And then routing. So how do you connect to Postgres? Well, simple, I write code like this here, right? Put some, that's probably PHP there in the first page, and Python or PSQL, so okay, put a host name and maybe a different port and who knows what. Problems here, right? 10, 15 years ago, that was cool because we just bought one big database server and that lasted forever. And when that one went down, we were down anyway. And okay, that was cool. We just had to fix that. Now we sort of fail over, fail around. We have slaves and we have all kinds of things. So hard coding host names is bad. And now we're all running in containers and stuff, so even hard coding port numbers is bad. And so this is not good. So you realize that pretty quickly and write a configuration system for or deployment system and deploy that maybe with a Puppet and then applications look into that to find their connection information. But even that's a problem because then your application has to monitor that configuration file all the time and then restart itself when it changes. So you have to basically implement a whole lot of logic if you want to be flexible with your configuration. So how about that instead? This is what we already had earlier, right? We have the application connecting to PG Bouncer and then down to the database. And then PG Bouncer only has to know where the database is, and the application doesn't have to know anything. The application only has to know that there's a local PG Bouncer running and connects to that. And then in PG Bouncer, you then have to develop this configuration system where all your hosts are. And here's sort of a typical way you could label this. And obviously these app numbers are not all that interesting. So you could have, you have different parts of your different databases. You have your order system, your customer system, or things like that. So we name those like that. And then back there, you can just tell where it is. And the application doesn't have to know that these are different databases or the same or what users or what ports, and you can change all that. And the nice thing in PG Bouncer is you can change this at runtime with, you change the configuration file and then you do a reload and it just sort of magically happens that your connections goes to a different place. Yes?
Previous picture.
Mm-hmm.
You're trying to represent that PG Bouncer is to live in app server, or?
That's what that is kind of trying to show, yes. There's some debates you could have exactly where you want to put PG Bouncer. You can put them on different hosts in different places, but this is sort of how I would design it for this particular case, that you run your PG Bouncer on your app server, close to your app server, right?
If I have 10 app servers, then PG Bouncer is the one who is going to manage the pool for all those app servers?
Well, what I've seen or what I would sort of propagate, advocate is that you have, if you have 10 app servers, you have 10 PG Bouncers running. Or hundreds. I've seen that. So, and I'll show some alternatives here, or some ways to augment that. But there are sort of configurations where you can have sort of many hops of PG Bouncers to configure and control different things. So, and then your code would look more like that. You kind of have to maybe hard code the port number of PG Bouncer. Hopefully you don't change that too much, but then you just have to use this logical database name That hopefully also doesn't change. And that's it. And hopefully you don't ever have to change that then, right? So, and you don't have to, the application doesn't have to be notified when your database location changes or anything. It really has to know nothing. So the problem is, perhaps if you do this and we have like tens or hundreds of app servers, and you have possibly designed a system like that, which maybe it's not terrible, but there's a lot of errors there. So the problem with that now is we have many of these different databases, and we have now all these very nice facilities in Postgres and extensions thereof that you can move these databases around quite easily. You can fail over and you can fail back, and you can set up replicas, and you can do all kinds of fun things. Now, if you have 3 app servers, well, maybe you just go in and change all 3 of them. Or if you have a configuration management system, you can go in there and change them maybe quite rapidly. But I have found that works, and maybe that's fine, and maybe that's as far as you go. But I find that also still cumbersome to. I've worked with systems where you really have hundreds of these app servers, or these are not just the app servers that are your well-defined web servers. There's also some random hosts out there that do some reporting or pulling some stuff out and sticking it somewhere else. And all these guys are connecting somewhere down here, and then once you need to fail over or move something around, you'll have to track all of these down and find them and somehow convince them to release their connection or get the new connection. And so that can be a problem once you go past a certain number of hosts. So a more interesting or more powerful system would perhaps look like that. And this kind of gets to your point that you very well have PG bouncers in multiple places. So this is sort of how I would build it out if it were a really big installation. That you have these local PG bouncers just to help your app connect quickly and avoid hard coding configuration information. But then you have a separate PG bouncer instance that just knows all the connection routing. And so if you move a database around down there, you only have to change it here. And all these sort of ad hoc places that need to connect to your database and do weird things and pull things out, or random scripts that do things, even those places just have to connect on this level and will receive the same benefits of not having to know where your database and all that stuff actually is. So now, of course, well, isn't that a single point of failure? Yes, of course. So you will want to have multiple of those. And how to do that, that's sort of up to you. There's, you use sort of standard techniques. You could use some kind of, hardware load balancer perhaps, or you could use, some kind of DNS or IP-based system, or even maybe some people will sort of stick an HA proxy somewhere in there. And there's sort of multiple ways, but they don't really have anything to do with PG Bouncer and Postgres. That's just because PG Bouncer doesn't have any state really that needs to be shared, so you can just use any kind of system to install multiple there. So you can put 2 or 3 in there, and that should be fine. And PG Bouncer is, as I mentioned earlier, is really, really quick for a large number of connections. So even if you have hundreds of application servers, say, you can really get away with 2 or 3 PG Bouncer instances, and they can easily handle tens of thousands of connections. So you don't actually have to have 20 or 30 of those. You just have a couple for if really there's a physical problem with the machine or something like that. All right. So, and this sort of ties into connection routing, and I mentioned, one of the reasons is what if you want to change something? And PG Bouncer has some commands and features that can help with controlling that. So again, you have this way to connect directly into PG Bouncer for some maintenance. And here's, for example, a command you can call. So this is not an SQL command. This is a sort of special command that you run inside the PG Bouncer. And then that would, as the name says, pause all the connections that are going to that virtual database. And why would you want to do that? This pauses the connections, but it doesn't break them. So the application doesn't know that you paused it. It will know that things are somehow slow and are not progressing, but from the logic flow, it doesn't know that your connection was paused. And then you can do maintenance. You can maybe reroute the connections, or you can make any of these changes that we alluded to. And then when you're done, you just say resume, and things just go on, and the connection logically continues. Of course, if you move your connection from one Postgres instance to another, it will know that you're now in a no instance because the session state does not carry over, right? So that's up to your application to handle. PG Bouncer cannot sort of magically transfer your session state, but you can do controlled failover and things like that if you just do pause, resume, things like that. So here's kind of how you could perhaps write a script, probably error checking and stuff in here, but this is sort of a way you can restart a Postgres instance. Maybe you want to do a minor version upgrade, or you want to change shared buffers or things like that need a restart, or move instance somewhere else. Then you could do this: pause, restart, resume. And again, your application doesn't know this is happening, but you have made the changes that you wanted to do. There's also this one, for example. This is also very handy if you're sort of in a really sort of large installation and there's a lot of random pieces that have accumulated over the years that are connecting in some place, and you want to, you always there trying to track them down and trying to make them stop. And this kind of makes it easier. Just go in there and just kill all the connections that come in through this one connection. And this is really the magic that PG Bouncer offers. This is the minus big R option. You can do an online PG Bouncer restart too, right? We have this architecture here that we sort of made up over this presentation that ideally you want to be able to change all these pieces without stopping your application. So I've shown a way PG Bouncer can help with online Postgres restart by pausing connections here or maybe here. And then you can do your changes and then you resume. And these guys up here don't notice. Now what if you want to change PG Bouncer itself? You have another PG Bouncer here, so you could kind of probably arrange that, but what if you want to change that one? So that's where this magic comes in. That PG Bouncer can actually, so you have a running instance, and what this R option does, it starts a new instance, and then this old instance transfers all the state to the new instance. And this sounds magic, but it actually works that way. It actually transfers all the open file descriptors and all the connections it has to the new instance, and then the new instance keeps running. So you can if you do it this way, you can restart PG Bouncer online and all the connections still work. Again, you have to see that to believe it, but it's really cool. So if you use a prepackaged PG Bouncer, you just want to make sure that the package in its script or whatever it is nowadays with systemd actually calls that, because whatever the packager or whoever put that package together, whatever they thought they were doing, they might actually just do a full restart. Do a full stop and then a full start, then you don't get the benefits of this. But I have gone through and then over the last couple of years to make sure that at least most of the popular packages, if you do a PG Bouncer restart, they actually do it that way. So that's pretty cool. So for a long time, PG Bouncer's sort of big problem was that it had very limited support for security configuration. If you connect directly to Postgres, you have all these facilities that always get in your way of connecting, right? You have pghba.conf, You have different methods of authenticating PAM and different password things, and then Kerberos perhaps, and you have SSL, and if you're a good sort of engineer, you want to use at least some of those to make sure your environment is reasonably secure. And PG Bouncer, until somewhat recently, didn't support hardly any of that. You had just basic password authentication. So that's about a year ago now, PG Bouncer 1.7 came out and basically fixed almost all of that, so that's really nice. It supports, TLS as it is called now, or SSL. It has a pghbr.conf that looks very similar to what you have in Postgres, so you can do connections, different authentication methods by IP address and exclude certain networks and all that. And you also have support for PAM authentication, for example, so you can hook that into your system-wide authentication, things like that. So if you're at all, if that's one of your requirements, that you have a secure access control, then you should look into PG Bouncer 1.7. If you just take whatever is installed in your operating system distribution, you will probably not get that quite yet. So for a long time, I've used PG Bouncer for probably 10 years now. And for a long time, we basically just worked around that by securing the network the database installation was running in. So once you're in that network, you're pretty free in what you can do, but it's kind of hard to get into that. So that was a big workaround, but now we have better facilities for that. So pain points. This before 1.7, this slide was much longer. So I kind of cut that back a little bit. So the main problem, if you set this up really, if you have a really big setup with all these local PG bouncers and then a couple in the middle with multiple for redundancies and things like that, and you can have even more layers if you really go nuts. You have all these pool sizes to configure, right? We had earlier pool size 20, reserve pool 5, and things like that, and you need to make sure all these match throughout. And you can consider this like a system of pipes that you're building with different widths or diameters, and that all somehow has to fit together through your entire stack. Because if you allow too many connections up here and down here, you've allowed fewer, then something will back up or burst, right, would be the analogy. So you want to kind of sketch that out, at least in your head somehow, to make sure this all makes sense. Because if you do this wrong, then sort of annoying things happen. And then you will have, if PG Bouncer cannot obtain, let's say you have your database server to your actual Postgres database instance set to max connections 100, say, right? But for some reason you set PG pool size 200. So PG pool will try to open up to 200 connections, but Postgres will reject it, and PG pool gets very upset. PG Bouncer gets very upset about that. And then it has sort of a back-off mechanism to make sure it doesn't go nuts, which is nice, but it doesn't really help your application keep working. And then basically everything slows down and it's a big mess. And if you have multiple layers of proxies of one kind or another, this whole issue backs up, and then your whole infrastructure becomes a mess. And you basically just have to go through and fix and restart a bunch of things and do this live is a big mess. So you need to make sure all these pool sizes match through an entire stack. And also if you have, let's say you have, in this setup here, let's say you have one in the middle and you set the pool size to a certain thing, and then you add more. For redundancies, you have to take that into account. Let's say you have pool size set to 100 here to connect to this guy who allows 100 connections. If you add more here, that multiplies that, right? So if you have this guy set to 100, you add more here, you have to divide that by the number you have here. Otherwise, you, again, overload that, because these guys don't talk to each other of how many connections they have at the moment. That might actually be a nice feature, but that obviously could cause other problems. So that's the main. The other thing I had here on the slide was like for a while, PG Bouncer was not maintained really super actively, and so it wasn't really quite clear of where it's going to go. But that has been addressed now. 1.7 was released with lots of features. Lots of people are still working on it, and well supported and well established in the Postgres community. And there's a lot of people you can find who can help you out with that. So that was addressed. So there's another project out there that you might have heard of that's called PGPool, which is sort of a competitor, you could say. And this is, I don't know too much in practice about PGPool to do a comparison, so this is not what this is about, but PGPool does have more features that can do more interesting things, like it can look at what queries you're actually sending and route them in different places depending on if it's a read or a write, for example. And that actually is quite hard to do. So PGPool actually has to do a lot of work to make that work. But with more functionality in this particular piece of code, possibly configuration is more complicated, performance could deviate, and possibly more issues and stuff like that. So if this is something of interest to you, you could compare PG Bouncer and PGPool for your application. I like PG Bouncer because it's simple and doesn't try to do too many things. Obviously, this is sort of, I'm kind of telling you all the things that PG Bouncer can do, but it's sort of these are sort of all different versions of the same concept, that it can manage your Postgres protocol connection to go to different places, or you can halt it and resume it. That's basically all this does, and then you can do multiple useful things with that. PGPool does a lot more because it inspects the protocol and then decides based on that. So these are the resources, and this has changed. Around the release of 1.7, all of this was moved to GitHub from old places, and then everything is sort of consolidated now. So there's a website in this GitHub place, which has news and some documentation. Documentation is really good, so you can read that, and it basically addresses everything. It doesn't tell you how to architect something for PG Bouncer, but it tells you how to actually use PG Bouncer. So I think sort of if you read the documentation and look at my presentation, it kind of combines well in terms of high level and low level information. And the code is on GitHub, and there's a lot of I could say please send bugs and pull requests, but there's actually quite a few right now, so we should work through those first. And there's, for discussion, there's Gitter, which, if you haven't heard of it, it's some sort of a chat thing nowadays that integrates with GitHub. So there's no mailing list at the moment, but you can use Gitter. Even there's an app for it, and there's also a web interface, so you can kind of use that as a mailing list / chat, and there's a lot of people on there, and you can reach the masterminds behind PG Bouncer if you have a question. So that is my presentation. We still have some time for questions. Yes, please.
So how does it perform if the connection is proposed by the PG Bouncer? If at the same time the application sends a request to the PG Bouncer?
Yeah, what happens to performance if the connection is paused in PG Bouncer with a pause command? Well, the application, it does not proceed in that case, right? But the idea is ideally you don't go in there and do that manually, but you do it as some kind of a script like this, right? If you want to do an online Postgres restart, you would do a pause and then the restart. Well, Postgres restarts can take a long time depending on checkpoint settings and all that stuff, right? So you gotta try that out or sort of worry about that before you do this. But if you have, if the restart takes a couple of seconds, yes, your application will be paused for a couple of seconds, but it's going to be much better than breaking the connection and then the application gets upset, and half the applications will not have any code to recover from that. So someone else has to go in and then restart web servers, and this is what usually happens, right? So the idea is you want to move all those worries out of the application to a different specialized layer. And then the application will halt, but it will proceed happily. Yeah. Yes, please.
Configuration about multiple databases.
Mm-hmm.
How pgBouncer knows which database to connect that? So does it make distinction by the DB names?
This is how you configure that. I kind of perhaps skip past that quite quickly. So your application code would look like that. You connect to pgBouncer using, depending on where it is, I suggested just keep it on the local host, but you can do it differently. So you got to tell the host and port that pgBouncer is running on. And then you use these logical, hopefully they're logical if you design them that way, logical application, database names. So in this case, app number. And how does it know what app 12 means? That's in the pgBouncer configuration file. So if a connection comes in for app 12, it will look here, okay, app 12 actually means connect to that host with perhaps additional parameters, right? You can put host, port, and all that stuff. And so that's really the meat of what you have to configure. That's what all these arrows, I had all these pictures of the arrows. This is where all the arrows get configured. Yeah. Okay. Thank you very much. I hope one more. Okay, let's do one more. Yes.
So you talked about pgBouncer configs in which pgBouncer mostly runs on the client side.
Yeah.
Same host as the client, but are there any setups where pgBouncer might be sort of like a reverse proxy running on the server?
Yes. Yes, so I could do sort of the second hour of this talk and do, I have worked with systems where there's, 3 or 4 layers of pgBouncers at different hops. So you could run it on the sort of the application side. You can run it sort of in the middle somewhere as a central point of contact. You can also run it directly on your database server. One of sort of the original ideas why pgBouncer was developed was for use by PL proxy, because PL proxy runs on a separate proxy host, but opens up a lot of connections depending on how you configure it. And one of the points was for pgBouncer to kind of narrow that down again. So yes, you can use it in all those. And once you grow, you will probably have a lot of those. You just kind of decide as you go, really. And it makes it very flexible that you can move them around and things like that, right? There was one more question. Yes?
Is there any reason that some of these features aren't part of like Postgres itself?
Aha, very good question. So, yeah, that's sort of a very, the question was why hasn't that sort of been moved or integrated into Postgres core in terms of connection pooling and things like that? Well, this works, first of all, right? So this exists and it works, and somebody would then have to go through and do this work again and go through all the political issues and work through the Postgres community to make this work. Yes, I mean, some kind of built-in connection pooling in Postgres core. There's a lot of people keep talking about it and would want it. I kind of like it being separate because even if I had built-in connection pooling in Postgres, I would still like to have a separate connection proxy for connection routing and then sort of safeguarding and things like that. Smaller pieces are often good. That's an open question, right? More questions.
Postgres itself, it has like 100 connection limit or so. How does pgBouncer pooling deal with that?
Well, it doesn't. You have to kind of set that up correctly. You set whatever connection limit you want to set in Postgres, and then you set hopefully the same connection pool size in pgBouncer so they match up.
Or deal with the limited availability in Postgres itself.
Can you rephrase that for me?
Because that, as documented, it has a limit to number of connections it can
Yeah.
have. So is there a way that pgBouncer or PGP works around that?
Yeah, the point of this connection pooling is that you don't actually, in practice, need that many active connections, right? If you just very sort of naively build up your application, you have 1,000 clients, and one database server. And so if you power that up, you're going to have 1,000 connections to the database. And that might work for a while. But in practice, you don't actually have 1,000 active queries running, so it is actually arguably better to run that through a connection pooler and only and sort of funnel that down to a small pool of connections that you actually actively use. And once the query or whatever is finished, that connection actually gets released. So I would have to sort of illustrate that perhaps with an animation, which I don't have. But that's sort of the idea that connections are probably idle most of the time, right? Because the queries actually run really quickly. And so you don't actually need that many connections. And you can sort of have PG Bouncer manage the idle connections, but only forward active requests to the database. Yes, please, in the back.
PG Bouncer running like an internal Postgres instance, or just speaking Postgres?
No, PG Bouncer does not have a Postgres instance itself. It's its own piece of code. It's a C code, uses libevent for network, managing the network. It has its own implementation of the Postgres network protocol, just to the extent that it knows what to do with it. It doesn't parse types and queries and things like that, but it knows what the protocol messages mean and decides what to do based on that. And that's actually not sort of the hard part. That sounds kind of like, whoa, all this work, but Postgres protocol is actually fairly simple, so that's because it's based on libevent, PG Bouncer actually only runs as a single process. So if you have sort of beefy machines you want to run PG Bouncer on, it's also plausible to run multiple instances in one machine and kind of bind them to CPUs perhaps even. I have sort of toyed with that a little, but in practice, PG Bouncer is so fast it doesn't really buy much, but it's possible perhaps. Question in the front here, yes?
How connection are shared? Like, is that if I have a different user or a different database where the connection can still be shared, or I have to have the separate connection?
So the question was, how are connection managed with different users and databases? Each connection, each pool uses a different user and different database. So if you want to have a connection with different users, for example, you have to have separate entries here. So this is kind of actually almost a sample of that. Let's say normally I connect as some kind of application user. And in this particular case, I want to connect as maybe a monitor user that has more privileges to do some admin stuff. So I need to set a different pool name or different virtual database name here. So you kind of have to fiddle a little bit with this to make a naming scheme for that. So if you have a setup with lots of different usernames, where that's not going to work super well through this. It will work, but you don't really take advantage of the pooling then, because you have to have a separate pool for each username. So maybe that will work, but you have to kind of check that out a little bit for yourself.
So which means essentially it's good for like I always have a same user against the same database, and that works.
That's right. So it's for this sort of typical modern web application kind of setup where you have sort of an application user and maybe a second user that has slightly different privileges and maybe a third one for monitoring. For that, it works really well. If you have something where every physical human user connects as their personal user account, it's not going to work super well, I think. It'll work, but you don't have any pooling for that then. Yeah. That's, yes, well, let's finish that and then we'll get to it.
So like say if I want to build a multi-tenant database, so I might actually give the different tenant a different user. So then that will not work where
you will just have more pools then, right? And then you have to see so if you have sort of hundreds of tenants and each tenant has a different user, that'll work because then you have hundreds of pools. That's maybe okay, but once it gets maybe into the thousands, if each tenant has then many users as well, then you have sort of multiplicative effect of pools, and that'll be a problem. Last question in the back, perhaps.
does PG Bouncer support
Does PG Bouncer support host failover? PG Bouncer does not have any sort of specific knowledge with failover. So that is something you build around it. And the previous talk here was actually kind of one way you could do that, which they didn't mention PG Bouncer, but there's, you could use, their thing was called Governor, or you can use Consul, or we have a product, Tech Quadrant called Red Manager, or any sort of system that orchestrates your failover would then just have some way to tell PG Bouncer to update its configuration. And that could be as simple as changing the configuration file with scripting, or you can have, Consul, for example, has like a template system that you could switch things around. That's the way you would build that around, and PG Bouncer would be the way where that system would tell where to connect or update the connections. Okay, thank you.